Good day everyone, welcome back to our discussion on the topic differentiation. Today we'll be discussing a subtopic function of a function, also known as chain rule. If we have a case like we are given a equation that y is equals to x plus 1 in bracket square. Now to differentiate this, our original approach will be to expand our bracket, that is we will expand x plus 1 in bracket square. That is why we become x plus 1 in bracket x plus 1. Expanding it will give us x squared plus 2s plus 1. Now to differentiate this, we treat this as a polynomial function and differentiate each of it individually. Doing so, our dy over dx will be equals to 2s plus 2. But let's say the power is very high, like we are giving something like y equals to s plus 1 raised to the power of 10. Now you agree with me that it will be very difficult to expand the whole expression out and begin to differentiate each of the constituents individually. Now to tackle this kind of problem, we use chain rule or function of a function. The chain rule states that if y is a function of u and u is a function of s, then dy over the s will be equals to dy over du times du over ds. Let us explain this concept using an example. We have an example here that states differentiate y equals to 3x squared plus 5 raised to the power of 4 with respect to s. First thing we are going to do is write our equation as y equals to 3x squared plus 5 in bracket raised to the power of 4. Now at this point we are going to introduce another constant to be equal to all the elements in our bracket. So for example, we can say let u be equals to 3x squared plus 5. Doing so, our original equation becomes y equals to u raised to the power of 4. Now the next step is to find du over ds, that is we are differentiating u with respect to s, and to find dy over du, that is differentiating y with respect to u. Doing so, du over ds will be equals to 6s, because when we differentiate 3x squared, 2 times 3 will be 6, and removing 1 from the power, we are left with 6s. 5 is a constant, we are not going to differentiate that, it becomes 0. Then dy over du will be equals to 4u raised to the power of 3 if we are using our general formula. 4 times u, then 4 minus 1 for our power, which is 4u raised to the power of 3. Now from our chain rule or our function of a function, it states that dy over ds will be equals to dy over du times du over ds. So substituting for dy over du and du over ds, it becomes dy over ds equals to 4u raised to the power of 3 times 6s. As you can see in our equation, we have two different variables now, which is u and s. To solve this, we are going to substitute for u in the equation. Remember initially we said u is equals to 3x squared plus 5. Now we're substituting u for 3x squared plus 5. Doing so, our equation becomes 4 in bracket 3x squared plus 5 close bracket raised to the power of 3 times 6s. Simplifying this by multiplying it, it becomes 24s in bracket 3x squared plus 5 raised to the power of 3. The correct option is D. We have another example. This example states that given that y equals to in bracket 2x to the power of 3 plus 2x squared plus 1 close bracket raised to the power of 4. Find the y over ds. We are given the options. Now solution, as usual, we write down our equation. Y equals to in bracket 2x to the power of 3 plus 2x squared plus 1 raised to the power of 4. Now we make our own bracket to be equal to another constant, that is let u be equals to 2x to the power of 3 plus 2x squared plus 1. Then doing so, our equation becomes y is equals to u raised to the power of 4. The next step is to find du over ds and dy over du. Now finding du over ds will be equals to differentiating 2x cubed to give us 3 times 2 6, then removing 1 from the power, we are left with s squared, that's 6s squared. Differentiating 2s squared, similarly 2 times 2 will be 4, then removing 1 from the power, it will become s, we are left with 4s. So du over ds will be equals to 6s squared plus 4s. well, if we differentiate 1, it becomes 0, because whenever we differentiate the constant, it becomes 0. Therefore, our dy over du will be equals to 4 times u, then moving on from the power, it becomes 4u raised to the power of 3. Next, at this point, we've gotten du over ds and we've gotten dy over du. Our chain rule states that dy over ds is equals to dy over du times du over ds. At this point, we will substitute for du over ds and dy over du. So dy over ds will be equals to 4u raised to the power of 3 times, in bracket, 6s squared plus 4s. At this point, we are going to substitute for u. And remember, u is equals to 2s cubed plus 2s squared plus 1. So substituting u into the equation back, we are left with dy over ds is equals to 4 in bracket 2s cubed plus 2s squared plus 1 close bracket raised to the power of 3 in bracket 6s squared plus 6s. Rearranging it, dy over ds will be equals to 4 in bracket 6s squared plus 4s in bracket, then 2s cubed plus 2s plus 1 in bracket raised to the power of 3. The correct option is C. We have another example from NECO. It states that differentiate the function with respect to s y equals to 4 divided by, in bracket, 2s cubed minus 6s squared plus 2s plus 1 raised to the power of 4. Now, the first thing we are going to do is simplify our right hand side. That is, we bring the entire denominator upward. So it becomes y is equals to 4 in bracket 2s cubed minus 6s squared plus 2s plus 1 raised to the power of minus 4. At this point, we make our entire bracket to be equals to u. That is, let u be equals to 2s cubed minus 6s squared plus 2s plus 1. Doing so, our y will be equals to 4u raised to the power of minus 4. Our next step is to look for du over ds and dy over du. Now, du over ds will be equals to differentiating u with respect to s using our general formula. It becomes 6s squared minus 12s plus 2, and our dy over du will be equals to minus 16u raised to the power of minus 5. Recalling our chain rule that states that dy over ds will be equals to dy over du times du over ds, we will now substitute for du over ds and dy over du. Therefore, dy over ds will be equals to minus 16u raised to the power of minus 5 times, in bracket, 6s squared minus 12s plus 2. At this point, we are going to substitute for u, and recall u is equals to 2s cubed minus 6s squared plus 2s plus 1. Doing so, our equation becomes minus 16 in bracket 6s squared minus 12s plus 2 close bracket, then in bracket again 2s cubed minus 6s squared plus 2s plus 1 raised to the power of minus 5. Removing our negative indices, dy over ds will be equals to minus 16 in bracket 6s squared minus 12s plus 2 divided by, in bracket, 2s cubed minus 6s squared plus 2s plus 1 raised to the power of 5. Our final example is from PC 2002. It states differentiate, in bracket, 1 plus 2s squared raised to the power of 4. Solution. As usual, we write down our equation. Y equals to 1 plus 2s squared raised to the power of 4. Applying chain rule, we make our entire bracket to be equals to z. That is, let z be equals to 1 plus 2s squared. Doing so, our equation becomes y equals to z raised to the power of 4. Our next step is to find dz over ds and dy over dz. Now, dz over ds will be equals to 4s, because if we differentiate 2s squared using general formula, it becomes 4s. 2 times 2 is 4, and removing 1 from the power, we are left with just s, so that's 4s. And dy over dz will be equals to 4z raised to the power of 3. 4 times z, and removing 1 for the power, we are left with 4z raised to the power of 3. Now, from chain rule, dy over ds will be equals to dy over dz times dz over ds. Now, substituting for dy over dz and dz over ds, dy over ds will be equals to 4z raised to the power of 3 times 4s. Multiplying this, it becomes 0 over ds is equals to 16s z raised to the power of 3. At this point, we are going to substitute for z. We know that z is equals to 1 plus 2s squared. Now, substituting z for 1 plus 2s squared, our equation becomes 0 over ds is equals to 16s in bracket 1 plus 2s squared raised to the power of 3. The correct option is B. We have some exercises for you to try your hands on at home. The answer to these questions are found in our Hidden Facts Further Mathematics textbooks. You can get the hard copy, or if you are interested in the soft copy, you can visit the website at the bottom of the screen. Thank you.